Great. Well, everybody, welcome back, or pleased to see you still here. Next speaker is Arjan Sieverink. That's a Dutch name, and I love Dutch names. It's the most easy thing for me, so that's great. University of Utrecht, one of the leading universities in the Netherlands, as you all know. The title of the presentation is Ricgraph, Showcasing Research in Context Using Pure and Other Sources. So with that, Arjan, the floor is yours.
Welcome everyone. Nice turnout. Thanks for coming. It's not a Jekyll and Hyde thing, by the way. Rick Janssen is a real person, and he's my colleague, and he's actually the founding father and developer of Ricgraph and tooling that comes with it. But he's not a pure guy. I'm the pure guy at University of Utrecht. So he gave me my marching orders and said, tell him. So that's what I'm going to do, but Rick does deserve a proper introduction. He's a well-esteemed colleague of mine. We work in the same department. We've been working together for 6 years now. And he's an open source and open science advocate. He works as a business analyst with us. And most of the time he's talking, does some more talking, and then writes it up in policy documents and so on. And but possibly due to a bore-out last year, he picked up his old trade and he went back to programming based on a number of discussions we had on how to combine data that's out there into an overview that is, on the one hand, more or less complete, but still human readable. Basically intended for inspection, for showing research in context. That's what Ricgraph, pun intended of course, stands for. And Rick sat down and started programming, and he came up with a wonderful solution tool and concept. He started out with a couple of what-if scenarios. So, and one of the main things was defining how to present the data, and we thought it would be wise to present it in a graph solution, which is just one of the types of database that's out there, which is easy to use. You just put things in, objects in, and define the relations between the objects. You don't have to worry about database schemas. You can add new data later on, and it seemed like an ideal solution for us to start getting to a point where we would have more insight into the data, look for data patterns, look for data anomalies, as they always are there, and have an easy tool to walk or traverse in graph terms, to traverse through the whole network of connected objects and retrieve information we needed in context and so on. There's a lot of data out there. Obviously, we do have Pure, and it's our CRIS system, and we do have a lot of information in there. But we do know it's not complete, and we do know that it can be enriched with other data, like data from our staff pages, from other sourcing systems like OpenAlex and so on. And there's we should differentiate between data we hold ourselves, like Pure and project control systems, and data that's openly available. And we'd like to bring them together and show them in relation to one another. So like I said, we chose to use a graph, which is simply a network of objects called nodes with their relationships, also called edges. And we decided to harvest a number of sources and write some example scripts. Well, Rick did all the work actually, but to write some example scripts of harvesting data sources and putting them into the graph database, which is Neo4j, by the way, but you can forget that right away. There'll be a link to the GitHub later on, and you can find all about it there. It only stores metadata, obviously, and it's intended to show research information in context. So different types of entities and how do they connect to each other. And one of the main advantages of a graph is that it's very fast in retrieving information. So queries designed for a graph can be simple or complex, nested, but they're still very, very fast. This slide shows an overview of the different types of information it's an example of the different types of information we use in our current setup for Ricgraph. Obviously there's information available to UU only, but there's also information openly available, like OpenAlex for our sister entity, the medical center, research software directory, and so on. We also use our own data repository system and staff pages, but actually there's much more out there which we could use and harvest, and it will be just a matter of writing the proper harvesting script in Python and add the data to the graph. Well, what's the point of Ricgraph if you can't do anything with it? Here are some questions we'd like to answer. And these are fairly simple questions, which you might retrieve from your pure only, but what you miss out on is the other sources you're harvesting, like OpenAlex. And what we've seen is that, well, it's probably an issue with most institutions present here, is that your pure may not cover all publications that are out there. Depending on which source you compare it with, Scopus or Web of Science, our university indicates that we cover about 60 to 80% of the publications, and well, showing and harvesting publications from other sources gives us a good insight in what we're missing. So that's one question you might ask the graph and get an answer to. And it's also very handy for visual inspection. So there's a lot of nodes. If you have a starting node, for example, a high-profile researcher, you can start with that node and look up all relations and go as far as you like. So the person he's working with, has worked with, research contributions he's made, and all other kinds of stuff. This is a kindergarten-like representation of what a graph looks like. Since we like to work person-centric or researcher-centric, in fact, those are the yellow nodes. This is an example of the different entities and their relationships shown in this graph. So you see the OpenAlex, Yoda data repository, and so on. This is a simple one. This is probably what we started out with. And then, without having to worry about database schemas, queries up front, or systems to be activated, or help needed from other departments, we added other entities like projects, skills, and skills actually are harvested from our UU staff pages. So it's very easy in such a graph setup to go forward and add entities without having to worry about connecting the dots. Well, you saw the questions earlier on. This is a visual representation of the answer you get from a graph and what are the research outputs of person A. And well, please observe Rick's amazing drawing skills as well. I'll compliment him when we get back. So this is one example. Another example is this one. So you see what kind of questions you can ask a graph and the type of answers you're likely to get back. Well, these are self-explanatory. This is an interesting one. This is the identifier part. It will come back in the conclusions, but one of the main things we found is that we really need identifiers, persistent identifiers, like a Scopus ID, an ORCID, an ISNI, or any other one, and that goes not only for persons, but for research outputs as well, so DOI, for organizations as well, an ROR or a Scopus ID. It's key to connecting the dots in a proper way. This is an example of what you could do with visual inspection. On the left-hand side, you see a network of Utrecht University nodes. On the right-hand side, the medical center nodes, and there's some kind of overlap. You can zoom into that by clicking on a node and traverse through the overlapping research outputs and other stuff, persons, and so on. And this is what I use myself to identify, for instance, issues with registration in Pure. So we have a very high-profile professor in the mass spectrometry division, and I looked him up yesterday, actually, and I noticed that there were publications that were present on OpenAlex, but not in the Pure representation in the graph. They were actually in Pure, but they were in a workflow status that was not published or not visible ready for the harvesting script. And I know this professor, and he's very disciplined, contrary to common law, in inputting his research outputs in Pure. He basically does it the same day the publication is published in a journal. So he would miss out on his personal staff page as well for the publications that are visible in OpenAlex but not in our Pure system. So these are the anomalies and patterns I'm looking for when inspecting visually. Then about some lessons learned. Like I said before, without identifiers, we're nowhere. It's key to, and this is an issue at our institution as well. We know we can register Scopus identifiers, ORCID identifiers in Pure as well, which would be a big help. But coverage at present at our university is about 35% for both. Despite campaigning by the library in the past few years. But since we can find those identifiers through other links, we do have them, and now we're looking at methods to populate Pure with those identifiers automatically. Well, a graph is the way to go. I hope you're convinced. I am. And it's not just a concept, it's a tool as well. You don't need a server for it. You can run it on your laptop. That's the good thing about it. So you can fiddle with the tooling. I must compliment Rick on the way he's documented the installation and setup process on GitHub. Worked for me. It's based on a Neo4j desktop installation and a Python installation. I myself prefer Docker images, so I got that working quite all right as well. And well, you do have to wait a bit for the harvesting processes to complete, but after that it's lightning fast, really lightning fast. And Rick has also thought of a graphical user interface, which is called Ricgraph Explorer. It comes with the package, and that's an easy way to visually inspect based on a starting node from a person, and you get an overview in the table format with all those research outputs, links to the research outputs, including the DOI links, so it's an easy way to traverse through the data. Any questions? Yeah, I was very late in the program, so I had a little hope that I would be on call yesterday, and I would have reserved the rest of the day to do demos. But you're very welcome to contact us. It's the next page. And we're very happy to organize, well, possibly probably online demos, help with setup, and if there are any tech persons around, we'd be very grateful for contributions to improving our Ricgraph coding, possibly new harvesting scripts for new sources. We like to, well, we're open source, open science minded. So we like to work in collaboration with you guys. Any questions? Was it that clear? Or didn't you understand the thing I said?
It could be a combination, right?
I think it's definitely a different way of looking at data and visualizing data and then trying to draw conclusions and maybe actions from it as well. So
yep.
I think people need to digest maybe a little bit as well, like how could we make that useful and valuable for us as well. So it may require some extra discussions even as well in the break, or but maybe some people have concrete questions already.
Hi, so Chris.
Rina from Denmark. You mentioned that there was data that was not in Pure, but you've found in OpenAlex. What do you do with the data you find in OpenAlex that's not in Pure? To import it or register it manually?
Oh, we haven't decided on that yet.
Okay.
We're just in the stage of discovering how Pure performs in relation to other sources. So how much do we have, how much do we miss? And it's merely intended to identify possible issues in our registration process and so on and so on. Yeah.
Hi.
There you are. I think you'll have to wait your turn.
Okay. Thank you. Chris from Lancaster. Just when we all know the challenge of people entering data into systems like Pure and things, I was just wondering how have the academics or departments reacted to seeing the data being presented in a different format than how we traditionally send it, which is you've got a blank field?
There's no official reporting through this graph or anything, but the researchers that we have spoken to, they're very enthusiastic because they can use the tool themselves, and they're able to find the connections they cannot using Pure, due to their limited access, of course, and well, yeah, I hope that's something of an answer.
You just more or less answered what I was going to ask. I think it is very interesting for researchers. We get quite a few questions from research. I work at the Technical University.
Yep.
That want data from Pure to analyze themselves. I think they would be very enthusiastic about this tool. I was also wondering, have you done more complex queries? So now you go like,
not yet. Yeah. Now I draw.
So would you like some use cases from that, or is that?
I would very much like to have use cases. Yeah. As I said, it's built on Neo4j, which has its own query language, which is called Cypher. And if you're well versed in Cypher, then complex queries are no problem. I myself intend to be well versed in Cypher, let's say in about 3 months. So I'm really going to put my back into it to define some complex queries on the data sets we have. Yeah.
Could it also be
and
used
we could we could use some help. Yeah.
Yeah. Because it reminded me also of the network graph on the Pure portal. I think that's something you could possibly do as well, right?
Yeah.
Is that the presentation for next year?
Well, I think it's still work in progress, and we'd very much like to do some kind of workshop, or a new presentation, but with just one condition. As to the venue, we had a buzz, or we started a buzz. Could it maybe be New Orleans? Or if I'm pushing it, Hawaii? Any hands?
So what happened to Iceland? It was Iceland yesterday, right?
We just need to organize a poll for it, I think. We didn't set it up, that's unfortunate. But,
okay, well,
yeah.
If anything, I'll vote for Hawaii.
Thank you.
Yeah. Okay.
Thank you very much for the presentation.
And you're welcome to visit the GitHub and contact us directly via our... we're on the staff pages ourselves as well, so please get in touch, get back to us, and we'd be happy to work with you.
Thanks again for the presentation.
Thank you.